Hi girls, today we're going to be continuing in Unit 4, Lesson 4.1.3, Interpreting Data Sets. So first we're going to talk about the concept of an outlier. An outlier is a data value that is much greater or much smaller than the rest of the data set. The problem with outliers is that they can lead to some misleading conclusions for different measures of center and different measures of spread. We'll look at an example of that, or two examples of that later. The other important thing to understand about these outliers is that if an outlier is present in the data set, you should always use the median for the measure of center, since the outlier will influence the mean. So the outlier will pull the mean towards itself, and then the mean will not be a good measure of center. So if there's an outlier, you need to remember to use the median, not the mean. So let's look at an example. So first I want you to go to your workbook page and tear out pages 35, 36, and 37. So here's page 35. So let's look at our problem. Our first example says, each student in Mr. Lamb's class measured a pencil. The data set below shows the pencil lengths in centimeters. What is the expected length of any given pencil? Describe the shape, center, and spread of the data. So the first thing we're going to do is reorder our data from least to greatest. Now they actually gave us a table here to use that. I'm only going to reorder the pencil lengths. I don't think it's important for us to reorder the student numbers. So from least to greatest, we'll put 10.2 here, 14.0, 14.3, 15.1, 15.6, 15.6, 15.7, 15.7, 16.0, and 16.1. Starting in our next column, 16.1, 16.2, 16.2, 16.5, 16.7, 17.3, 17.8, 17.9, 18.6, and then 19.0. So when we look at our data, we can already tell that it looks like we might have an outlier. This 10.2 really doesn't seem to be very close to the rest of the data. But we're going to use some numbers to calculate that. So the first thing we're going to calculate, it says, is the inner quartile range. And what does the inner quartile range mean? The inner quartile range is the distance between the first quartile and the third quartile. So we're going to take our third quartile and we're going to subtract our first quartile, because to find the distance between 2 points, we subtract them. Now, we haven't even found our median or our first quartile or our third quartile. So let's find those first. I know that I have 20 data points, so my median would be between data point 10 and between data point 11. Data point 10 and data point 11 are both 16.1, so my median would be 16.1. So I have 10 data points in my lower half of data, so my first quartile would be halfway between 5 and 6. 1, 2, 3, 4, 5, which would be right here. They're both 15.6, so Q sub 1 is 15.6. I go over to this group of data. I know that my third quartile is going to be halfway between these, 1, 2, 3, 4, 5, so it's going to be right here. So for my third quartile, I have to find the mean between these two numbers. So 16.7 plus 17.3 divided by 2, that is going to give me a third quartile of 17. So in order to find my IQR, my inner quartile range, I would take 17 and I would subtract 15.6, which gives me an IQR of 1.4. So how does this help us? Well, the next thing we need to do is take that IQR and we're going to multiply it by 1.5. So 1.5 times my IQR of 1.4 gives us 2.1. Now we use that number, the 2.1, to help us determine if we have any outliers at the lower end of our data. So when we go back and look at our data, we are looking to see, do we have any outliers at the low end of our data? So we take our first quartile, in this case, Q sub 1, and we subtract away the 1.5 times the IQR, 2.1. So that would be 15.6 minus 2.1, and that gives us 13.5. So what that means is an outlier would be considered any number that is below 13.5. When I go back to my data, I see 10.2 is below 13.5. So we are going to consider 10.2 an outlier. So we're looking for, remember our first quartile is right here, and it equals 15.6. So we're looking to see any number that is greater than 2.1 away from there. So when we take 15.6, subtract away the 2.1, we ended up with 13.5. So any number less than 13.5 qualifies as an outlier. Now we need to check to see if there's an outlier at the upper end of the data. So in this case, we look at our third quartile, which was right here, and we said it was Q3 is 17. So we need to see, are there any numbers that are greater, 2.1 greater than that? That would give us 19.1. No, there aren't any numbers greater than 19.1. So we don't have an outlier on the upper end. We would take the third quartile and we would add 2.1 to it. 17 plus 2.1, 19.1. So in this case, we do have an outlier, or we don't have an outlier. So we're going to list all the outliers, and the only outlier that we found was 10.2. So next it says, based on the measure of center, this will give us an approximate expected value of any given pencil based on Mr. Lamb's data. So the next thing I think we should do is let's create a box plot and see what this looks like. So let's get our number line right here. I'm going to put our low value at 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That seems reasonable. So 12, 14, 16, 18, 20. So we determined, let's go back up to our data. Our data shows us we have a median of 16.1, so that's right about 16. We have a first quartile of 15.6, that's going to be very close, and a third quartile of 17, also very close. So we create our rectangle. My minimum value is the 10.2 over here, and my maximum value is at 19. So I put my dots at my min and my max, and now I connect them. Notice how long this tail is with an outlier. Whenever you have an outlier, it will have a very long tail. So sometimes just by looking at your box plot, you would be able to determine if you have an outlier just by looking at this. Now, if we were to take the mean or the average of all of these, this outlier would pull that measure of center closer to it. So in this case, the best data point to use, or the best measure of center for us to use, is the median. So in this case, if we wanted to know what is the expected length of any given pencil, we would say that the expected length would be the median in this case, 16.1 centimeters. All right, let's take a look at another example. Kayla is trying to estimate the cost of a house painter. She receives the following estimates in dollars. She takes the mean of the data and states that the estimated cost of a house painter is going to be $1,610.73. Is her estimate correct? So she took the data points, and she has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. She added them all together, and then she divided by 11 and found the mean. So let's try a different measure of center. Let's try our median and see if we get a different answer. So I'm going to rewrite these from lowest to highest. So 1045, 1150, 1288, 1347, 1547, 1553, 1604, 1640, 1842, 1844, and 2858. All right, once again, I think just by looking at our data, it looks like we have an outlier here just based on the points. But let's go through the process and find all the information that we need to find. So the first thing I'm going to do is find my median. I have 11 data points, so I'm going to have 5 on one side and 5 on the other. So my median is going to be 1553. So my first quartile, 1, 2, 3, 4, 5. Q1 is going to be 1288, and 1, 2, 3, 4, 5. So Q sub 3 is going to be 1843. Next thing I need to do is calculate my interquartile range. So my IQR is going to be, the third quartile minus the first quartile. So 1843 minus 1288, which gives me 554. Next, I need to take 1.5 times 554, and that's going to give me 831. So this will help me determine if we have any outliers. So the first thing I need to decide is, are there any numbers that are 831 away, that are farther away than 831, lower than the first quartile? So that means I'll take the first quartile and I will subtract 831. So 1288 minus 831 is 457. Do I have any data points less than 457? No. We don't have an outlier on this side. Now we need to look here. It appears we might have an outlier, but let's double check. So I take my third quartile, and I need to see that's 1842. Do I have any points that are greater than that by 831? So we're going to add 831 to the third quartile. 1842 plus 831 gives us 2673. Do I have any points that are greater than 2673? Yes, I do. So I'm going to list my outlier as the point 2858. So a better estimate of this data would be our median. So we would estimate that the cost of a painter would be $1,553 rather than the $1,610 that she estimated. There is another way that we could calculate and estimate the cost of a painter. One of the things to do is to go back to our original 11 pieces of data and decide we're just not going to count the outlier at all. So I'm going to come up here and I'm going to cross out the outlier. And I'm left with 10 data points. So now I'm going to find the mean without the outlier. Without the outlier. So I'm going to add those 10 points up, divide by 10, and when I calculate the mean without the outlier, I get 1486. This also would give you a good estimate as to what the house painter would cost. So the two different ways to calculate when you have an outlier would be to take the median, or if you wanted to, you could get rid of the outlier and take the mean of the remaining points. All right, so the last thing I'd like you to do for homework tonight is look at example number 3. We're not going to do this one together. I will read it with you. I want you to actually write your answer to this, and we'll take a look at it tomorrow in class. So it says the National Basketball Association has strict guidelines about the dimensions of basketballs used during games. The circumference of the basketball must be between 749 millimeters and 780 millimeters. A basketball manufacturer is sending a shipment of various brands of basketballs to the NBA. Brandon notices that the mean circumference of the balls is in this range, so he decides to send all the balls to the NBA. The NBA gets the shipment and is not happy. Many of the balls in the shipment do not have the right circumference. What could have happened? How could the mean circumference be in this range, but many of the individual balls have the wrong circumference? So based on what we've talked about in all 3 lessons in Unit 4, in addition to what you've just heard about outliers, write down an explanation as to why the balls that he sent to the NBA were not the right circumference. See you tomorrow.